All right, here's a review problem for, let's see, the check with, I guess, sorry, the third test that talks about graphing a parabola. So in general, here's what I've got. Instructions say, I guess number one, I'm going to find a pen first. Number one, find the x-intercepts, y-intercepts, vertex, axis of symmetry, reflection point to the y-intercept, or a reflection point in general. Domain and range, I guess, will come increasing, decreasing. We're not going to talk too much about that. And sketch the following. So I'm going to, in general, just throw away increasing, decreasing. Probably not going to talk about that. Sketch the following. Okay, sketch. Big idea, but sketch the following by finding x-intercepts, y-intercepts, all these things up here. Domain and range will come later. All right, so what I've got is right here, x squared. I've got a quadratic equation, x squared plus 12x minus 28. What's my x-intercept? Well, let's see. X-intercept happens when y is equal to 0. And I would say, well, y is equal to 0. Sorry. I would plug in y equals 0. If y equals 0, then f of x equals 0. And I would find that 0 equals, all I'm doing is plugging in y equals 0 here. 0 equals x squared plus 12x minus 28. And all I'm doing is graphing this guy, or sorry, not graphing it, graphing it eventually, but I'm going to find out what my x-intercept is. X-intercept happens when y equals 0. I've got this function here, 0 equals, or this equation, 0 equals x squared plus 12x minus 28. All I'm doing is got to factor this out. So 0 equals x here and x right there. I got to find two numbers that multiply together to get negative 28, add up to positive 12. I'm going to say one would be negative 14. One would be positive 2. Negative 14 times positive 2. Sorry, it's an ugly negative 14. Negative 14 times positive 2. Negative 28. Sorry, negative 14 times positive 2 would be negative 12. So I'm going to have to change those signs. It should be a plus 14 and a minus 2. Because they both would add up to 14. Positive 14 times a negative 2, negative 28. Positive 14 plus negative 2 adds up to positive 12x. So there is my factorization. And all I'm doing is trying to solve this. Sorry. If I've got this factorization form, or sorry, the factored form, now all I do is say either x plus 14 equals 0 or x minus 2 equals 0. 0, there we go. And now solve. Subtract 14, subtract 14. I got x equals negative 14. Same token, add 2 to each side. Dot, dot, dot. I got x equals positive 2. X-intercepts, negative 14, comma 0, and 2, comma 0. Because for each one of these, I found out that y equals 0. Here's the y component, 0. Here's the y component, 0. I found out that x equals negative 14, x equals 2. There's 2 points right there. X-intercepts. Y-intercepts are actually a little bit easier to find. So if I'm going to take a look at the y-intercepts, y-intercepts happen when x equals 0. If x equals 0, I'm going to just evaluate this at x equals 0. If x equals 0, I got a point here, 0, comma, some value. What's that value? Plug in 0 here, and I find that f of 0 is 0 squared plus 12 times 0 minus 28. And I'm just taking numbers from right up here. Evaluating at x equals 0. Y-intercept happens when x equals 0. If x equals 0, evaluate this for 0. I got negative 28. Negative 28 should be my y value. There's my y-intercept. What's my vertex? Well, if I've got my equation in general form, 3 terms, vertex happens when, hang on a second, vertex happens when x equals negative b over 2a. A equals 1, b equals 12, c equals negative 28. I'm just pulling out numbers. 1, here's my a, here's my b, here's my c. Signs go along with the coefficients. I'm plugging in numbers now. Negative b is negative 12 over 2 times a. 2 times a is 1. Negative 12 divided by positive 2 is negative 6. Vertex is at negative 6, comma. What's my y value? My y value is evaluate this when x equals negative 6. And all I do is find f of negative 6. F of negative 6 is negative 6 squared plus 12 times negative 6 minus 28. And all I do is just evaluate that. F of negative 6 equals 36. Negative 6 squared. Careful with this. Negative 6 squared. If you plug it in the calculator, make sure you get parentheses around the negative 6. 36 minus 72 minus 28. And now I just evaluate that. We evaluate that at 36 minus 72 minus 28. Pull out the calculator. Negative 64. Negative 6 comma negative 64 is our vertex. Axis of symmetry. Axis of symmetry actually happens when, or at the vertex. So we can say that axis of symmetry happens when x equals negative b over 2a. Well, we found that out earlier. X equals negative b over 2a is x equals negative 6. That's our axis of symmetry. X equals negative 6. All right, let's put some of these points out here and say I've got, let's see, I've got an x-intercept, negative 14, 0, positive 2, 0. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've only got 10 points here, so let's make each of these, let's say 2, 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10, 12, 14 would be one of our x-intercepts. Hang on a second, I'll put this in red. X-intercept would be right there, negative 14, 0. X-intercept also is at 2, 0. So there'd be another point right there. So there would be our two x-intercepts. Y-intercept, 0, negative 28. Let me see if we can change that to blue. See if we can get that down there. And 0, negative 28. Here's my 0 in the x direction, negative 28. And I've got to go to, first of all, negative 28 in the y direction, but also negative 64. So we got only 10 spots here. So we make each of these 10. I got 10, 20, 30, 40. I'm going down to the y-intercept of 0 and negative 28. There's negative 10, there's negative 20, there's negative 30, so negative 28 would be somewhere right about in there. I'm going to put a dot right about there. That would be 0 and negative 28. Vertex is at negative 6, negative 64. But you know what? Before we even do the vertex, I'm going to put the axis of symmetry in there at x equals negative 6. X equals negative b over 2a. I'm going to put that in there as my axis of symmetry. X equals negative 6. Here's 2, 4, 6. Right there would be my axis of symmetry. Right here is my axis of symmetry. Going up and down like that, right about there. And the vertex is at negative 6, right on that axis of symmetry. And negative 64, here's 10, 20, 30, 40, 50, 64, right about there. Not going to be perfect because we've got, you know, spots of 10 here, tick marks of 10. So there's about where my vertex is. All right, so in general, there's a couple of points. I know that my A is positive. A is positive 1. So he's a positive guy. He's walking around with a smile on his face. The vertex is going to, or sorry, the parabola is going to be a smile. It's going to open up. So there is, let's see, the vertex, 2 x-intercepts in red, 1 y-intercept. So we've got the x-intercepts in red. Hang on a second, let's go and put these out there. X-intercepts are going to be in red. Y-intercepts, yeah, let's see, what are those? The y-intercept is blue. Change that to blue. Y-intercept is in blue. Vertex and axis of symmetry actually are, vertex and axis of symmetry are both in green. So there's all the points that we've got. Now I'm going to take that reflection point to the y-intercept, and then we'll find our domain and range after we sketch the following, after we sketch all the stuff. So I've got my reflection point. After that, we've got some information down here. So find the reflection point. The reflection point is the reflection point of this point here, this blue point, this y-intercept. The y-intercept actually talks about the y-intercept in blue, and the y-intercept, in fact, all these points are symmetrical. These points here, the x-intercept, symmetrical with respect to that axis of symmetry. They're equidistant. From here to here, from negative 6 to negative 14 is 8 points. from negative 6 to positive 2 is also 8 points. These are 8 points away from the axis of symmetry. Here, this is from negative 6 to 0 would be a distance of 6. So if I go into another distance of 6 this way, over to this point here, I'm going to color this as blue. You know what, I'll just use black just to make sure. So if I'm going to go equidistant from here to here, over in this other direction, to the left direction, to the negative x direction, I would go 2, 4, 6 over here, and about that same point I would have a reflection point of that y-axis, or sorry, the y-intercept. And there would give me, all of my points here would give me an idea about what my parabola is going to look like. This is again drawn freehand, not a great parabola, but that's about where my points are. My x-intercepts, my y-intercept, my vertex in green, my axis of symmetry in green, where x equals negative b over 2a. The black point is the reflection point of that blue point, because it's equidistant from the axis of symmetry of that point there. And there's our reflection point. Reflection point would be negative 6, negative 12, negative 12, negative 28. So that negative 28 is the y-intercept right here. At 0, negative 28. Also at negative 6, negative 28 is our reflection point. So now from our graph, we can easily see domain. Domain is again the x values. So let's take a look at, I'm kind of running out of colors here. I guess I'll just stay with black. Domain would be the x values. What x values can go into this? Any x value can go into it, because from negative, this parabola would go up forever and ever and ever. This parabola would go up forever and ever and ever. It goes to infinity and beyond. So really, all real numbers would be our domain. Range would be the y values. We'd stop right down here, or start, I suppose, and go up to infinity here. So my range would be y would be greater than or equal to this value right here. There's my minimum value. What's that minimum value? Vertex is negative 6, negative 64. Y equals negative 64 is my minimum value. So y has to be greater than or equal to negative 64. And that's my range. Where is it increasing? Officially be increasing from my axis of symmetry to the right. So it'd be any values x greater than negative 6, my axis of symmetry, decreasing over here. So it'd be decreasing over here all the way up to this point here at x equals negative 6. So really x is less than negative 6. All these values over here is where the function is decreasing. All these functions over here is where the function is increasing. And there is just a general idea about how to graph from a general form of an equation, f of x equals x squared plus 12x minus 28, general form to find the x-intercepts in red, y-intercepts in blue, vertex and axis of symmetry. First of all, I suppose find the axis of symmetry at x equals negative b over 2a. Then find the vertex. Then you can reflect the point on the y-intercept, and then put all those points together and graph it.